Trebuchet. The trebuchet was medieval Europe's ultimate siege weapon, capable of hurling 300-pound stones over 300 yards. It appeared in two forms. The traction trebuchet came first, arriving in Europe around 500 AD from China, where teams of men yanked ropes to swing the throwing arm. Then around 1200 AD, engineers developed the counterweight trebuchet, replacing human power with a massive weight box filled with stones or lead. Here's how it worked. The throwing arm pivoted on an axle, with the counterweight on the short end, and a sling on the long end. Operators winched the arm down, loading the counterweight high into the frame. They placed a projectile in the sling, then released the arm. Gravity pulled the counterweight down with tremendous force, whipping the long arm upward. At the peak of the swing, the sling released, launching the stone in a high arc toward castle walls. The counterweight version could smash through fortifications that had stood for centuries. Mangonel. The Mangonel was a torsion-powered siege engine that predated the trebuchet in medieval Europe. Romans used earlier versions, but the design peaked between 800 and 1200 AD. Unlike the trebuchet's gravity-based system, the Mangonel relied on twisted rope bundles made from hair, sinew, or hemp. A wooden arm sat inside these twisted rope skeins. Crews cranked the arm backward using a winch, twisting the rope bundles tighter, and storing energy like a massive spring. They loaded a stone or incendiary projectile into a bowl or sling at the arm's end, then released a trigger pin. The twisted ropes violently uncoiled, snapping the arm forward and flinging the projectile toward enemy walls. The Mangonel fired faster than a trebuchet, but with less range and accuracy. Its name often overlapped with the onager, another Roman torsion weapon, though the onager typically had a single upright frame, and the Mangonel used a horizontal configuration. Both delivered devastating rapid fire during prolonged sieges. Ballista. The ballista was essentially a giant crossbow mounted on a frame, firing oversized bolts or stones with lethal precision. Ancient Greeks developed the first versions around 400 BC, and Romans perfected the design, which medieval armies inherited and modified through the 1400s. The weapon operated on torsion principles, similar to the Mangonel. Two vertical frames held tightly twisted rope bundles made from sinew or hair. A bowstring connected two arms inserted through these rope bundles. Operators used a winch and ratchet system to pull the bowstring backward, cranking the arms into the tensioned rope skeins. This stored massive spring energy. They loaded a bolt, sometimes 6 feet long, with an iron tip, into a central groove. Releasing the trigger sent the arm snapping forward, driving the bowstring and launching the bolt at incredible velocity. Ballistae could pierce armor, impale multiple soldiers, or punch through wooden fortifications at 400 yards. Larger versions called Springalds fired stone balls. The ballista's accuracy made it ideal for picking off defenders on castle walls or destroying siege equipment. Battering Ram. The battering ram was the simplest and oldest siege weapon, dating back to ancient Assyria around 900 BC and used throughout the medieval period. At its core, it was just a massive tree trunk, often tipped with an iron or bronze head shaped like a ram's head, suspended by ropes or chains inside a wooden frame. Crews of anywhere from 12 to 50 men swung the log backward, then drove it forward repeatedly against gates, walls, or door hinges. The frame, often mounted on wheels, protected the operators from arrows and boiling oil poured from above. More advanced versions included a protective roof covered in wet hides or metal plates to resist fire. The ram's effectiveness came from concentrated, repeated impact on a single point, fracturing mortar, splintering wood, or loosening stonework until the structure gave way. Some medieval rams weighed several tons and required specialized crews who worked in rhythm, chanting to coordinate their swings. Castle defenders countered by lowering cushions or hanging chains to absorb the impact, or by dropping heavy stones to crush the ram's frame. Fire arrows and incendiary projectiles. Fire arrows and incendiary projectiles were among the most feared siege weapons, designed to burn wooden structures, spread chaos, and force defenders from their positions. These weapons appeared in various forms across centuries, but became particularly sophisticated during medieval sieges from 800 to 1500. AD fire arrows started as simple arrows with cloth wrappings soaked in pitch, oil, or resin, tied behind the arrowhead, then ignited before shooting archers aimed at wooden gates, siege equipment, thatched roofs, or stored supplies. More advanced versions used small clay pots, filled with naphtha or Greek fire, attached to arrow shafts. Larger incendiary projectiles came from catapults and trebuchets, which launched clay pots, barrels, or wicker baskets filled with burning pitch, sulfur, quicklime, and other flammable materials. These burst on impact, spreading fire across wooden fortifications or into crowded courtyards. Some projectiles contained mixtures that couldn't be extinguished with water, clinging to surfaces and continuing to burn. Defenders countered by soaking wooden structures, keeping water barrels ready, and using wet hides as protective coverings. The psychological effect was devastating because fire threatened not just military positions, but food stores, shelter, and escape routes, often forcing surrender faster than starvation or assault. Greek fire siphons. Greek fire siphons were terrifying flamethrower devices that sprayed liquid fire at enemy forces, particularly effective in naval warfare, but also used during sieges. The Byzantine Empire developed this weapon around 670 AD, and the exact formula remained a closely guarded state secret for centuries. The incendiary mixture likely contained petroleum, quicklime, sulfur, and naphtha, creating a substance that burned on water and couldn't be extinguished by conventional means. The siphon itself was a bronze tube mechanism mounted on ships or fortress walls, resembling a large pump. Operators heated the Greek fire mixture in a pressurized chamber, then used a piston pump or bellows system to force the liquid through the bronze tube. At the tube's end, the mixture ignited, possibly through a pilot flame or chemical reaction, shooting a stream of sticky burning liquid up to 50 feet. The weapon created psychological terror because the flames clung to ships, siege equipment, and even soldiers, burning intensely and resisting water. During sieges, defenders positioned siphons on walls or towers to spray attackers, approaching with siege towers or rams. The weapon's effectiveness declined after 1200 AD, as the secret formula was partially lost and alternative incendiaries became available, but its reputation as an invincible fire weapon persisted throughout medieval literature. Perriers and Springalds. Perriers and Springalds were torsion-powered bolt throwers that bridged the gap between ballistae and smaller artillery, firing large projectiles with significant force. These weapons became prominent in European medieval warfare from 1200 to 1400 AD. The Springald operated on similar principles to the ballista, but with a more compact design. Two vertical frames held twisted rope bundles, typically made from horsehair or sinew. Wooden arms inserted through these bundles connected to a bowstring. Crews used a windlass to draw back the string, twisting the rope skeins and storing energy. Unlike ballistae that fired bolts, Springalds launched a variety of ammunition, including large darts, iron-tipped spears, or stone balls weighing up to 50 pounds. The Perrier was similar, but sometimes used a single arm sling mechanism rather than two arms with a bowstring. Both weapons excelled at destroying enemy siege equipment, smashing through mantlets and testudos, or delivering precise shots against specific targets, like siege tower crews or defenders manning particular wall sections. Their accuracy exceeded catapults and mangonels, making them valuable for surgical strikes during sieges. The relatively compact size allowed mounting on castle towers or inside siege encampments. As gunpowder artillery emerged in the 1400s, these torsion weapons gradually became obsolete. Ribauldequin. The Ribauldequin was an early medieval volley gun that fired multiple projectiles simultaneously, representing a bridge between traditional siege weapons and true firearms. This weapon appeared in European warfare during the 1300s and 1400s as gunpowder technology spread across the continent. The Ribauldequin consisted of multiple small-bore iron or bronze gun barrels, typically anywhere from a dozen to 50 tubes, mounted in rows on a wheeled cart or wooden frame. Each barrel was loaded individually with gunpowder and small iron balls, stones, or lead shot. The barrels were positioned parallel to each other, aimed in roughly the same direction. Crews ignited all barrels simultaneously or in rapid sequence, using a linstock, a long pole, with a slow-burning match at the end. Touch-to-touch holes drilled into each barrel. The resulting volley created a devastating spray of projectiles that could shred infantry formations, destroy lightly armored troops, or sweep defenders from castle walls. The psychological impact was enormous, as the thunderous roar and smoke cloud terrified both men and horses. However, the Ribauldequin had significant limitations, including slow reload time, limited range of about 200 yards, and the inability to aim individual barrels. Despite these drawbacks, it proved effective in specific tactical situations and influenced the later development of organ guns and other multi-barrel firearms. Bombard and Cannon. The Bombard and Cannon represented the revolution that ended the age of castles, introducing gunpowder artillery, capable of smashing through walls that had stood impregnable for centuries. These weapons emerged in Europe during the early 1300s and dominated late medieval warfare through the 1500s. Early bombards were massive wrought iron or bronze tubes, sometimes over 15 feet long and weighing several tons, built by welding together iron bars and reinforcing them with hoops. Craftsmen loaded gunpowder through the muzzle, then added stone balls that could weigh 500 pounds or more. A touch hole at the breech allowed ignition with a hot iron or slow match. The explosion drove the projectile forward with tremendous force, capable of punching holes through masonry walls up to 20 feet thick. Crews needed hours to load and aim these monsters, and misfires or barrel bursts killed operators regularly. As metallurgy improved, cannons became smaller, more reliable, and easier to maneuver while maintaining devastating power. By the mid-1400s, bronze cannons with standardized bores could fire iron balls repeatedly at ranges exceeding 1,000 yards. The fall of Constantinople in 1453 demonstrated their power when Ottoman bombards breached the legendary Theodosian walls. Castle architecture adapted with lower, thicker walls, angular bastions, but the age of vertical stone fortifications was essentially over. Mortar. The mortar was a short-barreled gunpowder weapon designed to fire projectiles in high arcs, allowing them to clear walls and land inside fortifications. This weapon appeared in the late medieval period during the 1400s, as gunpowder artillery diversified beyond direct-fire cannons. Unlike long cannons that fired relatively flat trajectories, mortars had stubby barrels set at fixed steep angles, typically 45 to 60 degrees. The short barrel length and wide bore allowed crews to load explosive shells, incendiary devices, or stone balls. Gunpowder charges were carefully measured, because too much powder could burst the barrel, while too little wouldn't clear the walls. When fired, the projectile arced high into the air, plunging down behind fortifications to strike buildings, supplies, or troops sheltering inside castle courtyards. This made mortars particularly valuable against cities and fortresses where defenders thought themselves safe behind walls. Early versions were crude and inaccurate, but experienced crews learned to adjust powder charges and angles to hit specific areas. Some mortars fired hollow iron shells packed with gunpowder and fitted with crude fuses, creating early explosive ordnance that detonated after landing. The psychological effect was devastating, because defenders had no protection from projectiles dropping from above. Mortars remained relatively rare in the medieval period, but became standard siege weapons in the following centuries. Trebuchet Disease Catapult. The Trebuchet Disease Catapult represented one of history's earliest forms of biological warfare, where besieging armies launched diseased corpses, animal carcasses, and contaminated materials over castle walls to spread plague and terror. This horrifying tactic emerged during medieval sieges from the 1100s through the 1400s, though similar concepts appeared even earlier. Armies used standard trebuchets, but loaded them with dead horses, cattle, or even human corpses, often victims of plague, dysentery, or other infectious diseases. The rotting bodies were flung over walls to land in courtyards, near water supplies, or inside residential areas. The goal was multifaceted: contaminate drinking water, spread disease through decomposition and vermin, destroy morale, and create unbearable sanitary conditions that forced surrender. Historical accounts describe the siege of Kaffa in 1346, where Mongol forces catapulted plague victims into the city, possibly contributing to the Black Death's spread into Europe beyond corpses. Attackers also launched barrels of excrement, diseased animal parts, and rotting offal. Defenders tried to quickly remove and burn contaminated materials, but the psychological damage was immediate. The stench alone was overwhelming, and the constant threat of infection created panic. While the actual transmission of disease through this method was likely less effective than direct contact or rat-borne plague, the terror and demoralization were very real tactical advantages. Siege crossbows. Siege crossbows, also called giant arbalests or Craniquin crossbows, were massive anti-personnel and anti-equipment weapons that fired enormous bolts capable of piercing armor and fortifications. These weapons evolved throughout medieval warfare, but reached their peak sophistication between 1200 and 1500 AD. Unlike handheld crossbows, siege versions were mounted on stands or frames and required mechanical advantage to draw. The bow itself could span 6 to 10 feet across, made from composite materials including wood, horn, sinew, and later steel. Drawing these powerful bows required windlasses, cranioquins with gear systems, or even multiple pulley arrangements, because the draw weight exceeded 1,000 pounds. Some versions needed 2 or 3 operators working together to cock the weapon. The bolts were essentially spears, 3 to 6 feet long, with iron tips, sometimes fitted with incendiary materials or barbed heads. When released, these projectiles could punch through wooden shields, pierce mail armor at 300 yards, or pin multiple soldiers together. Siege crossbows were particularly effective for precision shooting during sieges, targeting enemy commanders, destroying siege equipment mechanisms, or clearing specific sections of wall. Their accuracy far exceeded other siege weapons, making them valuable for surgical strikes. The main disadvantage was slow rate of fire, typically only a few shots per hour, but each shot carried devastating potential